Today we'll learn about the second part of the distributive property, where instead of just having a constant out front of the set of brackets, we'll have a variable term.
In our distributive property part 1 video, we looked at how an expression can be multiplied by a constant. The question might have looked like this, where there is a 2 out front of the brackets. Now we are going to look at what happens when there is a 2x in front of the brackets. As we saw with the area models, when a term with an x multiplies with another term with an x in it, we get a term with an x squared. So when we multiply 2x with 4x, we multiply the coefficients, the 2 and the 4, to get 8, and then the x's to get x squared. When the 2x multiplies with the negative 10, we get negative 20x. And that is how we use the distributive property to expand or multiply. Before we look at our next example, we need to know what happens when we multiply an x by an x squared. If we expand what we know from an area model, we know that an x squared is made up of an x multiplied by an x. If we multiply an x squared by another x, then it's like multiplying an area, measured in centimeters squared, by another dimension measured in centimeters. We know that this would give a volume measured in centimeters cubed. Similarly, when an x is multiplied with an x squared, we get an x cubed. When there are 3 terms inside a set of brackets, we will need to multiply the term out front by all of the terms inside the brackets. So minus 3x multiplied by minus 4x squared will give us a positive 12x cubed. There are 3 parts to consider when getting that. The sign, a negative, times a negative is a positive. The number, 3 times 4 gives us 12. And the variable, x multiplied with an x squared gives us x cubed. To find the second term, we will multiply the negative 3x with the positive 3x. The sign will be negative because it's a negative times a positive. The number will be 9 because 3 times 3 is 9. And the variable will be x squared because x times x is x squared. Finally, we will multiply the negative 3x by the negative 1. The sign will be a positive because it's a negative times a negative. The number will be 3 because 3 times 1 is 3. And the variable will be x because x is not being multiplied by another variable, so the exponent will not change. It's important to note here that the resulting expression cannot be simplified any further because there are not any like terms that can be collected. Each term has a different exponent on its variable. There will be cases when you might need to apply the distributive property more than once in a question. Like when there were just constants out front of the set of brackets, we will need to look carefully at the terms which will need to be multiplied. In this question, the negative 3x will multiply the terms in the first set of brackets only, and the 5x will multiply the terms in the second set of brackets. Negative 3x times 2x will give us negative 6x squared. Negative 3x times negative 4 will give us positive 12x. Positive 5x times negative 4x will give us negative 20x squared, and positive 5x times positive 2 will give us positive 10x. At this point, we can see that some collecting of like terms can happen. We can accomplish this by rearranging the terms so that the like terms are beside each other. The negative 6x squared can be placed next to the negative 20x squared, and the positive 12x can be placed next to the positive 10x. When we combine the negative 6x squared and the negative 20x squared, we will get negative 26x squared. When we combine the positive 12x with the positive 10x, we will get positive 22x. And there we have it. We now know how to use the distributive property to handle terms with variables out front of the brackets in addition to those with just constants out front.